Guess we should be live. A bunch of things. Let me turn off. Right, that's turned off. Okay. I'll monitor the sound. Do we have the sound from the desktop? Yep, we have the sound from desktop. Need more gain on my microphone because I'm already pretty close to it. The problem with that gain is that after there's some sort of safety mechanism that reduces it back to 100%. It's now more than 100%. Yes, there can be. There is a possibility of something being more than 100%. It's called gain. Well, one way of calling it is gain. So I have this robotic, there's some sound to it. This sounds pretty annoying. We did some work on the sound. Well, one of the bots did some work on sound, but we'll need more work on it. More work on it. Okay, now we have too much gain. Now we have too much gain. Too much gain, too much gain. Okay, so I have the code for this. The code will be also on the page. Page should be available to you as well. Okay, so I had a prompt about the sound. And looking at the code, trying to find the demo bit. Demo bit, demo bit. Can't believe how we're looking at the code ourselves. This is crazy. This is crazy. Oops, I just delete. What's the search? A demo. So we have this demo button. Well, we have 70 mentions of demo in the code. We have this demo toggle button that mentioned 8 times. Okay, we have the state playing true. We have some comments through the code, which is a bit weird. Don't need the comments because we weren't intended this not for the code is not for humans, is it? And we have the 3 of these demo actions. Now, one thing we wanted to do is actually go agent mode, the Claude Sonnet 3.5 in agent mode. Okay, so we have the demo in the demo cycling. The demo actions are not changing. Actually, I'm thinking for the demo actions, can we have a list? Can we have a list for the demo actions? Instead of the next button, we can just select the action from a list. Currently, we only have 3, so that shouldn't be a problem. It should fit the screen nicely. And this will also show us which action is currently playing. And the other thing is that we want in the demo mode to cycle through the demo actions as well at a reasonable timing. So we want each one to play 2 or 3 cycles, 4 or 5 cycles maybe. Cycles, not seconds. And then move on to the next one. So currently we have should have a list of 3 and just scroll through it during the demo. And again, once we interact with the canvas or any of the controls, including the demo action list, that we can also manually select the demo, manually select the action, the play demo should stop. Okay, we need to fix the text to speech is the speech to text is not great. We need to fix a few things. Well, hopefully Claudette want to make it gender neutral, be smart enough to actually deal with any spelling, I wouldn't say mistakes, I would call them inconsistencies. So let's just send that to Claudette. I would actually give it to Gemini as well. See which one does better. I mean, Claude in agent mode is actually modifying the code directly. Gemini is working in the browser. So we'll have a second version of the code if it generates the whole script. I don't know if it will. That's Gemini 2.5 Pro. Okay, so replace the next button with a drop down, populate the drop down, implement automatic cycling, make each demo run a few cycles, ensure any manual interaction. So yeah, it got all the all the tasks from my poor explanation, and it's actually generating the whole code as well. Claude did it as well directly in the code. Right, so we have the drop down, which is good. Then we have wave, reach, grip, show. Then play demo, should go wave, should automatically change. Yep, so it played a few cycles, reach, and then should go to grip, show. So that's very nice. Claude agent mode, thank you very much. We have a version from Gemini as well, but don't have a good feeling about it. I don't even know if the code is complete or not. I suspect not, but this one is working. That's exactly what we wanted. We also have a professional podcast on this. Between a comedian and a data scientist. So just have a discussion about this application, and we will keep testing in the background. If you have any questions, pop them in the chat. Everything I do is available on BioniChaos.com. So go check it out and provide your feedback.
So, what do you think? Pretty neat, right? It's a forward-off prosthetic. So, what do you think? Pretty neat, right? It's a forward-off prosthetic arm simulation.
A 4D. Is this the world's most advanced tool for scratching a niche you can't quite reach? It looks like a minimalist crane game where the only prize is existential dread.
It's 4 degrees of freedom: shoulder yaw, elbow pitch, wrist pitch, and the gripper. See, you can control each joint with these sliders.
Degrees of freedom. My last apartment had 1 degree of freedom. The door. Okay, so this one, ooh, it's surprisingly smooth. It feels organic.
That's the goal. It's all calculated in real time with forward kinematics. We tell the joints what angle to be, and the code computes where the endpoint, the end effector, lands in space.
Forward kinematics. Is that what you call it when you confidently walk into the wrong room? My kinematics were forward. My destination was speculative.
Something like that. It's the opposite of inverse kinematics, where you'd tell the hand where to go, and the code would have to figure out all the joint angles to get it there. That's much harder. This is more direct.
This is the no, you do the work version of robotics. I respect that. What's this play demo button? I feel like I'm about to see a robot's interpretive dance.
Exactly. Click it. It's running a pre-scripted sequence called Wave.
Oh, look at it. It's waving. It's waving with the enthusiasm of a royal who's been doing this for 6 hours. It's the most polite, soulless wave I've ever seen. What's next? Politely requesting a high five?
The next one is Grip Show. It demonstrates the gripper mechanism. The core idea is to create a synthetic environment to generate training data.
Data, of course. For a data scientist, the whole world is just a data set waiting to be collected. You see a prosthetic arm, I see a tool for perfecting the world's most passive-aggressive handshake. Now hold on. Turn on the sound. Check the little box.
Ah, the sonification. I mapped movement velocity and gripper pressure to the audio context.
Sonifit. What? It's humming. Is it happy? Scared? It sounds like a dial-up modem having a mild anxiety attack.
The pitch goes up as the gripper closes, and the volume increases. With the speed of movement. It's another layer of feedback for a potential user. Instead of just sight, you get an auditory cue for force and speed.
So the more it's trying, the more it whines. I can relate. This is brilliant. You haven't just built an arm, you've given it a voice. And this voice is saying,
You joke, but that's the point. We're trying to bridge the gap between user intent and mechanical action. The future directions part talks about integrating EMG signals, electromyography, reading the muscle signals in a person's residual limb to control the arm.
So my bicep thinks, grab coffee, and the arm just does. And it hums a little, I'm grabbing coffee tune. Sign me up. But why this whole simulation first? Why not just build the arm?
Because failure is cheap here. We can run 1 million virtual trials, refine the control algorithms, and train a machine learning model on all that data without ever building a physical prototype. Look at the code. It's all in one file. The arm's entire personality is defined in this little JSON block.
Shoulder yaw, min -90, max 90, rest 0. It looks like the arm's Tinder profile. Loves long walks on the canvas, can reach for things, seeks user with good intentions, swipe right to activate the gripper.
That's one way to put it. It makes the system incredibly modular. Want a longer forearm? Just change the length equals 100 to length equals 150. The whole simulation adapts.
I'm looking at your future directions, ball catching challenges, grasp stability metrics. This is all very noble. I have some suggestions.
I'm almost afraid to ask.
You. Advanced stand-up comedy module. The arm could hold the mic, and if a joke bombs, it performs a perfect rim shot on a virtual drum, or a subtle disappointment gesture for when someone tells a long, pointless story.
I'm not sure that's a priority for amputees, Yozik.
You're thinking too small. Imagine a feature for perfectly stealing one French fry off a friend's plate. The fry pilfer protocol. The data you could collect on stealth and human indignation would be priceless.
We're trying to install function and create an intuitive extension of the human body. It's about empathy, translated through data and engineering.
I get it, I do, and it's amazing. But don't forget the fun. The first thing I do with this is teach it how to dramatically flip a table. You can't tell me that's not a core human function.
I'll add it to the bottom of the future directions list.
Excellent. Now, if you'll excuse me, I'm going to see if I can make it look like it's trying to conduct a very small, very confused orchestra. The humming really adds to the performance.
There's also a human in the loop. If you have any questions, go for the chat. Otherwise, everything do eventually available on BioniChaos.co. Go check it out. Provide your feedback. Also have Patreon if you want to support the project. You can also do it on YouTube itself by becoming a member. Don't forget to like, dislike, subscribe, unsubscribe. You know what to do. We have another version of the code. Let's have a copy that Gemini made. The original one was almost 500 lines. The new one is 400 lines. So it's a bit odd. What did it change and why? Was it only like 100? Where did 100 lines of code went? Where did? They look pretty identical. The demo meant to cycle through the actions. Yes, it does. Yeah, so everything seemed to work. So why is it 100 lines shorter? Got rid of something, didn't it? So this one's Gemini and that one is Claude. Both working the same way, so grip show, wave, can select the... Oh, right. So when you select the demo action, one sec, if I go in Visual Studio Code, do a format document, it's making 633 lines of code. Yeah, so the lines of code business can be misleading, can it? Okay, so I have the two versions. Question is, yeah, we have a couple of weird things. So if we're stopping the demo, selecting different, what? Okay, so there's actually, yeah, I found the difference. I found the difference. If we stop the demo, select a different demo action, it will not actually perform the action. Whereas this one, if we select the demo, it will actually start the demo, which makes more sense. So there we go. So we know which code we are getting rid of. Keep this one. It's better. Gemini did something weird. It got rid of some stuff in the code. Is the script complete, or did you get rid of something that we had before? And are there any placeholders? Just as Gemini, but then, yeah, Claude, Sonnet 3.5, agent mode, having much more success. It says the script is complete, nothing was removed. Yeah, not sure. Anyhow, I think it's hallucinating on me, so start a new chat. Okay, let's move on. We will publish this. We had this data set sitting on the server. that we were converting. Those were MAT files. Kind of learned the hard way not to use MATLAB files anymore. Supposedly it converted them into JSON successfully, but then we had trouble. Well, because the JSON files were too large, so on and so forth. The usual stuff. Yes, MATLAB file is a binary, so yeah, we could have converted it into another binary, but that didn't make sense for us to display something reasonable on the page. We need the data in legible JSON. Legible JSON. So nothing binary, nothing funny. No funny formats. A MATLAB format also suggests that something was done to the data prior, which we don't like as well. And yes, there was. So essentially, it's not the data coming from a device. It was pre-processed quite heavily. Yeah, let's talk to one of the boards.
All right, buckle up for a tour of BioniChaos.com, where biomedical data meets technology and education. The site has a search bar, a section for all tools, and an audio overview. They have some fun interactive simulations. One is a smartphone neck simulation, where you can see how much extra weight your neck carries when you tilt your head to look at your phone. The other is an enhanced interactive gait analysis simulation, which looks like it lets you explore kinematics and gait phases with a modern user interface. Is there anything in particular that you would like to explore further? Okay, I can help with that. From what I see, the website is called BioniChaos.com. It seems to be a platform that combines biomedical data, technology, and education, offering interactive simulations for researchers, educators, and students in biomedical engineering and neuroscience. Would you like me to focus on a particular aspect or section of the website? On the screen right now, I see simulations and tools related to various scientific concepts. There's a circular motion illusion that connects to trigonometry, a quantum wave function simulation exploring quantum mechanics, a Hodgkin-Huxley action potential simulation for neuronal membrane dynamics, and an HRF image database viewer. Have you had any experiences with simulations like these before, and do any of these topics particularly pique your interest? Okay, scrolling down, I see an interactive magnet simulation that explores magnetic forces and field lines, connecting to physics principles. Below that is predictability versus creativity, a guide to deterministic and generative AI. Then there's an advanced hair cell simulation and an interactive physiological signal visualization tool, followed by an interactive TMS simulation to visualize transcranial magnetic stimulation effects on the brain. How do you think understanding magnetic forces or AI predictability could play a role in biomedical data analysis or the creation of new medical technologies? Scrolling down further, I see an action potential architect, interactive neuron simulation, an interactive spectrogram generator, and an interactive brain EEG simulation. Below that, there's a Fourier series visualization. If you were a biomedical engineering student, does any of these tools capture your attention, such as the EEG simulator? As I scroll down, I see AI that understands why, causality, and LLMs, which explores the future of intelligent systems through interactive demonstrations. Then there's high-fidelity Fourier simulation, the multimodal medical data landscape and interactive report, interactive guide to EEG technologies, Cochlear Limited, a visual analysis, and neurofeedback, an interactive evidence review. Which of these topics sounds most compelling or relevant to current discussions or advancements in biomedical engineering or data science? It sounds like the neurofeedback and interactive evidence review is something interesting to you. Could you tell me what specifically about the neurofeedback interactive review sparks your attention? Okay, scrolling down the page, I see AI-powered EEG speech decoding, a modality comparison bubble chart, a cochlear simulator, and finally, an advanced EEG signal simulator. For the viewers watching, what do you think about these tools? What sort of feedback would you provide to the developers of this website to make it more engaging and fun?
Okay, there's obviously a human in the loop. If you have any questions, go for it. Now, what developing this robotic arm, the demo mode now works okay. It's actually cycling through this demo actions, wave, reach, grip. Everything we do is available on BioniChaos.com. And I'm looking at this data set that we currently have on the server. thinking if we should just get rid of it or not. And let's see if it actually, if the HTML normally, if the HTML is not showing anything useful, we will probably be getting rid of it. But we have two of them. Yeah, this is the BFRB. Forgot what it stands for. Let's load the index HTML. It's actually displaying stuff. Ooh, it's 300 megabytes in the, oh come on, in the browser. That's a bit weird. Has some mistake over there. Yes, we had this data set. It's a gesture distribution. So using this funky wearable, custom wearable, no one cares. It's not commercially available, so it's a one-off. That's another problem actually. And it had all these motions, gestures, done supposedly by people with some sort of OCD or something. That repetitive motion. What it stands for? Dashboard provides. What it stands for? Repetitive behavior, something. And I had this bunch of gestures. Had different counts, so it's essentially a missing data set because you have like some actions, repetitive motions were counted more commonly than others, so it's labeled. Yes, this is an example of forehead scratch, and we have the accelerometer and a TOF. It's a time in flight, whatever. Essentially a proximity sensor that shows you proximity to the face. Don't know how well and that will indicate anything. We had another sensor as well, our temperature, which is actually not shown here. I don't know why. Yeah, and essentially we're trying to replicate Kaggle results. And in pre-training, we had a very great scores. It was essentially promising us to do better than the first place Kaggle competition, which ended, by the way. But when we were running the training on the entire dataset, the performance would have was dropping significantly. Yeah, I don't remember the exact numbers, but yeah, it was essentially promising 90% performance during pre-training, and then it was dropping to bugger all. So it's extracted certain features based on which supposedly would be able to make the classification. As you can see here, the features are overlapping quite a bit. So essentially, it's the difference between whatever pink and green that we will be trying to detect. But as you can imagine, it will be quite hard. Yeah, there are peaks there. Yeah, there's no distinct difference looking at this selected features. Yes, so wasn't very successful. I didn't use the temperature at all. Did it just mention temperature? And no. Anyhow, we would not be training on it anymore, so we can get rid of the data set. Kegel evaluation. If we get rid of the, just rename the folder for a sec, see if the HTML, if the dashboard will still load. It should load. It should load, okay. All right, because we also have 1 gigabyte for the dataset and another 1.2 gigabytes for the pre-processed stuff. Pre-processed stuff. First sequence CSV. I'm not sure if it's safe to get rid of. Yeah, we spent quite a lot of time on it, unfortunately. Probably shouldn't have. Yeah, we did it after the Kaggle competition, so we weren't trying to win the competition, whatever. We were just essentially trying to reproduce the results or potentially make the model even better, whatever. But yeah, we had some mixed success. We had some mixed success. Okay, we have this speech cortex. There's also 20 gigabytes. 20 gigabytes. What? Why is it not showing up? I know it is. Oh, that's the one we actually. Yeah, we have this. Yeah, that's the MATLAB files. That's another data set. Yeah, we'll get rid of that one first. We do have a copy of it. Yeah, that's the problem with like scientific literature and stuff. So it's fine. They made the paper open source. They open sourced the dataset as well. problem, and they say that the dataset is what's required to reproduce the results in the paper. Well, problem with that is that the dataset is heavily pre-processed. So yes, of course, you can reproduce the results of the paper, but there's a caveat that the data is not raw. So it's not coming from the device. They talk about neural data, but the data is actually not neural. It's heavily processed, pre-processed, whatever. So that's a bit of a problem. That's why we're cleaning it out and getting rid of. It's called speech cortex. Yeah, they were essentially reproducing. They didn't have much success. I don't know. It was like in a big journal, whatever. But they themselves, the success of the models, the performance of the models wasn't that great. They were essentially trying to reproduce the speech that the patient was thinking about. I think that those the BlackRock whatever, the Utah array, whatever it's called, the patients, BlackRock patients that had the implant, the recordings, electrodes in the motor cortex, and they were trying to reproduce the speech thoughts. Well, that didn't go very well. Yeah, I think we'll just get rid of the whole thing. Yeah, we covered it before. We had some videos on it, so fortunately it was just a waste of time. It's the problem with a dataset. Essentially, there will be like some sort of process of determining if we should look at the dataset or not, by looking mainly, first of all, one of the main criteria is if the dataset is a raw data, or is it heavily processed, pre-processed. Even if it's slightly pre-processed, it's already not very useful. Yes, we're getting rid of speech cortex. Move to trash. We didn't even feed the trash. It's like 20 gigabyte. It's a 20 gigabyte thing. Okay, so generally everything we do is available on BioniChaos.com except this one. It's essentially, there will be videos remaining of it, but we just can't store 20 gigabytes of data. We're trying to do training on it. It didn't work. Oh, that one we didn't even start the training because we had some trouble parsing those MATLAB files. Well, because we don't have MATLAB. So that's the other thing. Yes, Python can do it, potentially convert it, but I think there was potentially some conversion issue from MATLAB files to JSON, whatever. So that one is Gonski. And I've been talking too much, so I get the robot to do the talking, unless we have a comment from a human, which I don't think we do. No, we don't. Yeah, go check out the website. Provide your comments. I can review comment live. But if there's no human to talk to, we'll just continue talking to a bot, unfortunately. but it's not set up at the moment.
Okay, on the screen, I see a dashboard titled BFRB Sensor Data Dashboard. It provides an overview of sensor recordings from the Helios wrist device, including model performance and feature analysis. It mentions that binary detection achieved strong performance F1 to 0.92, but gesture classification remains challenging F1 to 0.54 due to overlapping feature distributions and difficult class separation. The analysis reveals that gesture classes 2, 3, and 6 are the weakest performers, requiring targeted feature engineering and data augmentation. Below this, there's a section on sequence gesture distribution, showing the distribution of gesture classes across recorded sequences. It highlights the identification of class imbalance and which gestures are most common in the dataset. The dashboard reports 8,151 total sequences, 18 gesture classes, 30,142 missing TOF rows, and 34,948 missing thermopile rows. There is also a bar graph showing the sequences per gesture for the full dataset. Is there anything specific you would like me to focus on or explain in more detail? All right, I see you are now in the Dataset Summary section of the dashboard and are looking at the visualizations. The dashboard is displaying different visualizations based on the selected Filter by Gesture. Currently, you're switching between different gestures using the drop-down menu. On the left, it shows the number of sequences, which remains constant at 8,151, and lists some of the gesture types. On the right, I see two plots. Per sequence mean ACC filtered, which shows the mean acceleration in the X, Y, and Z directions, and average TOF sensor 1 filtered, which displays the average time of flight sensor data. The plots change depending on which gesture you select from the Filter by Gesture drop-down menu. Would you like me to elaborate on a specific gesture, or perhaps explain what the different plots represent? Of course. The Model Performance section presents the latest model training and evaluation results. Key findings indicate that binary detection achieves strong accuracy with an F1 score of 0.92, while gesture classification performance is suboptimal, with an F1 score of 0.54 due to significant feature overlap between gesture classes. The analysis highlights that classes 2, 3, and 6 pose the biggest challenges, with F1 scores of 0.40, 0.45, and 0.45, respectively. Do you want to get into the details of binary detection versus gesture classification, or should we explore how the model performs with different gesture classes?
So essentially there were two metrics for the performance of the model. One was binary, is the gesture repetitive behavior or just a random gesture, and that's 98% correct. That's a binary classification. Now, out of the gestures that are repetitive motions, it essentially was not able, based on this sensor data, to classify which gesture it was. Yeah, That's pretty much it. You can go to the original Kaggle competition, see how, what are they doing. It's not actually clear what they're doing. I don't know if anyone has written up the results or not. Maybe we could look at it again, see if we can replicate the results of the first, second place. Yes, their scores were much higher, but I don't know. Yeah, essentially were not able to replicate. Pre-training was giving very high scores, overall scores for both, like 0.9. But when we actually trained on the whole data set, we were getting the scores was dropped. Specifically this gesture classification score was dropping to 0.5, which is almost a random. Well, I mean, a 50.5 would not mean random because you have all these different classes and it's not binary classification. I don't know what you can calculate what's random, based on this many classes, what would be a random score. But essentially it's not great. It still means it's not able to classify. You can see the confusion matrix. You see, yeah, the model gets confused, mainly over here, over there. So essentially some of these gestures are very similar. So the sensor data is very similar between different gestures. So I don't know how. This is a custom wearable so I think that data is essentially one-off as far as we're concerned. And I don't know how the competitors in Kaggle went about it. We were not able to do anything useful, so the model essentially underperformed. Yeah, performed poorly. So I don't know if we need a write-up on this or not. Maybe we will leave it as a write-up. It's just that I'm not sure what data we need to keep for this dashboard to still display something useful. Can obviously ask the bot. Claude. We gave it the entire folder. Well, because currently the whole folder is 2.5 gigabytes. Because we have some raw data in it. Now the question is, so looking at the HTML of the dashboard presenting the results and the folder, we want to essentially get rid of all the files that are not required to display the dashboard correctly. So if any of the data files are not used currently for rendering the HTML dashboard, we would like to get rid of them. Can you do it for us? You got access to the folder and the HTML code? Let's try it out. We can try it out. Yeah, then it actually went into selecting, looking at specific features. We did that training like several times, 3 or 4 times. You can actually go ahead and use the terminal to get rid of the data files or any files that are not used for displaying the dashboard, the HTML dashboard. So add this to the prompt. This is Claude Sonnet 3.5 agent mode. Got the HTML, got the folder, it got a terminal, got, well, pretty much can take over. Can take over everything. Okay, so it's reading the folder. Interestingly, it's doing it in the chat as opposed to using the terminal. Let me create a to-do list to organize the cleanup task. Okay, while it's doing it, I'll just mention that everything we do is available on BioniChaos.com. Go check it out and provide your feedback. Ideally, we'll be talking to humans rather than AI robots, soulless. Okay, so it's actually generated a bash command, a terminal command, but it's just I'll use the terminal to remove unnecessary files while keeping the essential ones in the for the dashboard. I'll be careful to preserve index.html, dashboard, JavaScript, feature analysis plots, thumbnail. Oh, what? Thumbnail? What's that thumbnail? It might be looking. Okay, let's. Okay, there is a problem. No, okay, so it's going to the correct folder. Oh, it's making a backup folder. Moving stuff into backup, so it's not actually deleting anything. Okay, that's okay, we will allow that. Okay, so what did it do? Still running. Kept on essential files. Just thinking it might have saved them in the wrong. No. Okay, removed all unnecessary files. The dashboard should now work. Okay, feature analysis plot. Okay, the main test is the dashboard still working? No, it's not. That's Claude the Sonnet agent. Well, it's kind of low risk because I was thinking getting rid of that whole project, but okay, there's a bit of a problem that after the changes you made, deleting some files, the dashboard is not displaying properly. Can you check? And that's using quite a lot of tokens as well, so we should have done it manually or something. if we revert, like we have the to do revert button. Maybe don't have it in this case because it actually deleted some files. Let's just see what it says in its own defense. It's actually broke a dashboard. Now it's trying to run the dashboard. Okay, go ahead, knock yourself out. It's checking what required. Let me check the content to verify the paths it's trying to access. Yeah, I don't think it actually checked the JavaScript. I see the issue is looking for files. Yep, and you got rid of them. That fixed by creating necessary directives and moving the files to there. Make the process what? Where are you gonna? Where are you gonna move them from? Okay, go for it. Okay, it's actually fixed it. That's interesting. Okay, restore the correct directory structure. Now let me restart the server. Okay, it's spawning its own server as well, in addition to. That's okay, because then it actually checks what's on the page somehow. Okay, so it is working as before. Those numbers are incorrect. The numbers. Okay, I'm getting frustrated with it. Yeah, we had two versions of this table. The rest of the numbers are there. Yeah, the rest of the tables are there. The first table is pretty sure is incorrect. I might just leave the YouTube videos and get rid of the whole thing. Because how big is it now? Because we're just chewing up tokens. We just chewing up tokens. And we'll have to finish up soon as well. So currently it's 2.5 gigabytes. Well, it used to be 2.5 gigabytes. That should be 1 or so. What? And it's a bit unusual. It would not actually show up in the folder. Oops. Yeah, I have to finish in a sec. Finish in a sec. Why am I not seeing it at all? How big is it? Open containing folder. No, now it's 26 megabytes. just fake some stuff? I don't get it. Yeah, I made a total mess out of it. I mean, the whole folder is much smaller now, but I don't think it's correct. I don't think it's correct. How big is it now? 45 megabytes. 45 megabytes. Yeah, don't think it's very useful. So we generate like a synthetic. We could be doing a new. If we start fresh on this, we could just generate synthetic data, similar to this, like brain recordings that will. I mean, you can train on synthetic data as well. It's not just faking it. Yeah, I'll just keep it for logging purposes, but yeah, there's not much we can do with this. So wave, bye for now. If you check the website, provide your feedback, and I'll touch on it next time. I'll see you tomorrow. Bye.